Today we will be focusing on question number 3 from the 2012 exam. I classify this as a type 3 question because we're interpreting graphs, and in this case we have a integral defined function. So g of x is the integral from 1 to x of the graph to the right. This is pretty standard fare for type 3 graphs. You either have a integral defined function or they give you the graph of f prime. But all of our interpreting graphs statements hold. So let's start with part A. Find the values of g of 2 and g of negative 2. So g of 2 is going to be equal to the integral from 1 to 2 of the function. And if we look at the graph, the area accumulation 0, 1, we're accumulating area from 1 to 2. That is a triangle. That is a base length of 1 and a height of 1/2. And because we are moving forward and the area is below the axis, it's considered negative accumulation. So negative accumulation, triangle is 1/2 base times height, giving us a value of negative 1/4. G of negative 2 would be accumulating in the backwards direction from 1 to negative 2. So we start at 1, and because we're working backwards and below would be positive accumulation. So we have a semicircle of radius 1. So a circle of radius 1 is pi 1 squared, and then if we make it a semicircle, that cuts it in half. And we wanted to back up all the way to negative 2. So we're going to then add this triangle, but because the triangle is above the axis, it is going to be a negative triangle, 1/2 base of 1, height of 3. So the semicircle is positive and the triangle is negative. Those two add together to be pi halves minus 3/2. For the free response scoring on this one, you get 1 point if you show the work that leads to the answer for g of 2. The second point you get if you show the work that leads to the answer. So make sure you're showing how these numbers are coming about. Generally, writing out the expression like this, and then the answer would be considered enough. Moving on to part B. For each g prime of negative 3 and g double prime of negative 3, find the value. So, in a integral defined function, we can apply the fundamental theorem of calculus by taking the derivative of the left-hand and right-hand side, and the fundamental theorem essentially tells us that the derivative of the integral is equal to the integrand. Technically, integrand evaluated at the top times the derivative of the top minus integrand at the bottom times the derivative of the bottom. But g prime of x equals f of x. Consequently, g prime prime of x equals f prime of x. So that's a relationship that oftentimes is really beneficial to write the moment you see a integral defined function. Our goal in part B is to evaluate g prime of negative 3. That's going to be the same thing as f of negative 3. And if we go to the graph, f of negative 3, 1, 2, 3 is right up here at positive 2. And then g prime prime of negative 3 would be asking us this: what is the slope of f at negative 3? And the slope at this point, we can see rise to, run to, it has a slope of 1. You can also do the difference quotient if you didn't feel comfortable calculating the slope visually. We can take 3 minus 1 over negative 2 minus negative 4. This is also worth 2 points. Stating the relationship between g prime and f to find the answer, and stating the relationship between g double prime of f to find the answer. Sorry, g double prime and f prime. I think the way that I've written out here is perhaps the most succinct way of showing all of the work needed for getting full credit on that part. All right, let's move on to part C. Find the x-coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine if it's a relative min, max, or neither. Okay, so G has a horizontal tangent line when G prime of x is equal to 0. And remember, recall, G prime is the same thing as f. So this occurs at two locations. It occurs at x equals -1 and at x equals +1. So now we need to determine whether this is a max or a min or neither. So this is considered a local max because G prime of x changes positive to negative. So that means essentially the slope of G is positive, then the slope of G is negative, which means the function G goes from increasing to decreasing. At 1, because the sign of G prime did not change, it was negative to negative. This is neither. So because the sign of G prime of x, which again, reminder, is the same thing as f of x, did not change. Okay, there's part C. The grading for part C, you get 1 point if you consider G prime being set equal to 0. You get 1 point for identifying the locations, and then 1 point for the justifications. So a total of 3 points. Let's move on to part D. Part D says, find all the values for which G has a point of inflection. So a point of inflection is where concavity changes. So G has a point of inflection where G prime prime of x changes signs. So we're looking for a spot where it switches signs, which means switches from concave up to down, or vice versa. Or in other words, where f prime of x changes signs. Or to put it another way, since we have the graph of f, where f of x changes increasing to decreasing or decreasing to increasing. So we're looking for essentially local maxes and mins for the graph of f. This occurs at x equals -2 and x equals 0 and x equals 1. So there's 3 locations. We're changing from concave up behavior to concave down behavior at -2. We're changing from concave down behavior to concave up behavior at 0. And then finally at x equals 1, we have concave up behavior to concave down behavior for the graph of G. This is worth 2 points. You get 1 point for the answer, and then 1 point for the explanation. And the explanation, they say, is that G prime prime, which equals F prime, changes signs. So they don't even get into the increasing, decreasing. All right, be sure to click that bell, get notifications, comment, like, subscribe, or smash that like button. Have a good day.